Welcome, ladies and gentlemen, to this motion problem. And this is problem 2. Let's begin. At 7 a.m., an automobile left a city traveling 48 miles per hour. How fast must a second car travel to overtake it in 4 hours if the second car leaves at 8 a.m.? Let's read the problem one more time. At 7 a.m., an automobile left a city traveling 48 miles per hour. How fast must a second car travel to overtake it in 4 hours if the second leaves at 8 a.m.? Let's move into the solution. So let's see what our solution is. Well, the first car traveled for 5 hours. The second car traveled for 4 hours. Let R equal the speed of the second car. Well, now from our distance time rate equation, we know that the rate of speed, the product of the rate of speed and the time of travel is equal to the distance. So this is the equation we're going to use to be able to solve this particular problem. So the product of the speed, time of travel, is equal to the distance. Well, now as you see here, we have set up a table with the rate, the time of travel, and the distance. For the first car, we were given that its rate of speed was 48 miles per hour. And we know that it traveled for 5 hours because the second car left at 8 a.m. and we were told that it needed 4 hours to catch up to the first car. Therefore, when it does, the first car traveled 1 hour longer. So we know the time of travel was 5 hours. And the distance traveled is D. For the second car, we don't know what the rate is. So that's the reason why we have the variable R here. And we were told that the second car will travel for 4 hours. And when it catches up to the first car, it's going to cover the same distance as the first car. So now we have the product of the rate and the time of travel for the first car, which is 48 times 5, which is equal to D. And we have the product of the unknown rate and time of travel for the second car, which is 4 times R, which is equal to D. So if you'd like to, please pause the video and copy this table and this information to look at how we proceeded in solving this particular problem. Moving on. Well, since we know that they cover the same distance, the distance traveled by the first car is equal to the distance traveled by the second car. And in this case, we know that 48 times 5 is 240. Well, that means that now we know that 4 times R should be equal to 240. So this is the equation we're going to use to find out how fast the second car should be traveling. Well, now we know we need to get the R by itself. And we see here that the R is being multiplied by 4. So that's multiplication. So in order to get the R by itself, we have to do the opposite operation. We must divide both sides of the equation by 4. On the left side, the 4's divide into one another once. We get R, 240 divided by 4. That gives us 60. So we see that the second car had to travel at 60 miles per hour. So as long as that second car travels at 60 miles per hour, it'll take 4 hours for it to catch up to the first car. Ladies and gentlemen, please let me know if this video instruction was helpful to you. My name is Mr. Joshua Davis. And my website is mathhealer.com. I would love it if you'd come by and let me know. Send me an email. My email is mathhealer@mathhealer.com. And let me know if this instructional video was helpful to you. Thank you for joining me and have a very pleasant day. Thank you.